Greetings and welcome to our last lesson in Unit 7. 7.5 is our lesson, page 301, talking constructions and scale drawings. We're finally getting to the scale drawing part. Use scale drawings to find missing measures. Our essential question, how can you enlarge or reduce a drawing proportionally? So, ladies and gentlemen, moving right along, you should have taken some notes from page 300, the key idea at the top of the page on scale drawings, where you wrote down and learned that scale drawings, scale models, there's two types. You've probably seen them. You might even be someone who's gone to the store and bought a model and built one. But anyhow, that they are either two-dimensional representations or three-dimensional representations of the actual object, the actual drawing, the actual building, the actual car, whatever. And that scale is a ratio which compares the measurements of the drawing or model to the actual object. Well, that's really important. That means if you were to look at that little study tip in the green box right to the left of the key idea, it says specifically, and I quote, scales are written so that the drawing distance comes first in the ratio. We always have to know that. That's a standard form so that no matter who gets somebody's drawing or who gets somebody's model, when they read the scale, they know it's the drawing or the model distance first. Outstanding. It's very important in the construction world. So moving right along, let's get find some of the actual distance. Airplane wingspan, a scale of 1 to 48. So there's a little bit of an error here. They're calling this scale, but actually scale must have units on it. 1 inch to 48 feet is what it really needs to be. So sometimes they misuse that. We're going to learn what it is when there is no units on it. But right now, scale should have units. Scale has units. A different vocabulary word is a scale with no units. So we're going to use that. And it just so happens, it also said that these scale drawings, these scale models, are proportional to the actual. So remember, a proportion is two ratios that are equal. And they just wrote the first ratio for you. 1 inch to 48 feet. And then you take what's left. Hey, they told us the model. So 18 inches. You always want inches to be consistent. So if inches is on the top of the first ratio, inches is on top of the second ratio. And the unknown goes down below. Taking our process that we learned to solve proportions, cross products, x would be equal to 864. So 864 feet. Always put units on your answers. Otherwise, they could be wrong. 864, if you wrote inches, you would be wrong. It's 864 feet. Going to our next one. Again, we need to fix that scale. That scale needs to say 1, again, inch to 87 feet. Well, this is another scale of inches to feet. That's the way it goes. It doesn't always have to be that way. We know they're proportional. We know that the first ratio is 8 inches to 87 feet. And that they gave us the actual 11 inches. Our unknown goes down below. We use our cross products. X is equal to 957. So that's 957 feet is the actual train distance. Okay? Moving right along, driving distance on a map, most likely, a scale of, well, now look at that. They gave us the correct one. 1 inch to 70 miles. That's what scales should be written in using units. And that is our first ratio in our proportion, 1 inch to 70 miles. And we know that the map says that we have to go 5.5 inches on the map. And how many miles is that? Doing our cross products, we get x is equal to 385 miles. Remember, units on your answers. Well, let's try finding the distance in the model or distance on the drawing. Either the drawing distance or the model distance. And this time it's a bridge span. And again, they gave us the correct ratio. And when they give us inches to miles, very good. And that would be the first ratio in our proportion, because we know that the distances are proportional when we're talking scale models and scale drawings to the actual. So 1 inch, once again, to 0.5 miles. Some of you may have noticed that typically in scale, the first unit given for the model or the drawing is typically 1. It doesn't have to be, it's just typically 1. So you're going to see 1 more often, but if you see one that doesn't have it, what if it said 2 inches to 0.5 miles? Then that's okay. It doesn't have to be 1, but it mostly is. And of course, we don't know the model this time, so that's our unknown. The actual is 7 miles. Using our cross products this time, we would get 0.5x is equal to 7 miles. Well, solving equations the way we know how to, we would divide by 0.5. Dividing by 0.5 is like dividing by a half. And of course, dividing by a half is the same as multiplying by 2, so we would get 14. And because this is the model, it's now 14 inches. If you wrote the wrong unit on it or didn't put any units at all, it would be incorrect. So please, again, units are important in this math process. Our rocket height, a scale of 1 to 15, they've done that incorrectly. It should be 1 millimeter to 15, excuse me, I almost wrote the other one, to 15 meters. That is the first ratio in our proportion, 1 millimeter, 15 meters. We don't know the model, so we're going to put that as the unknown, and we know that the actual rocket is 9.9 meters. Doing our cross products, we get 15x is equal to 9.9. Dividing by 15, we find that the model is pretty dang darn small, because if it's 15, we divide by 15, we get 0.66, and that would be millimeters. That would be millimeters. Now, so that's kind of crazy small, but it is what it is on a model. I don't know who would make a model that small, but that's how it works out. That's exactly how it works out. So going to our first quick write, find the base of a treehouse. The treehouse scale says is 1 to 21. Scratch that. Please put 1 inch to 21 feet. And then here's the actual, so please find the model. Please find the model. All right? Please find the model distance, remembering to write your proportion. Take a quick break. Come on back. We'll talk a little bit about some scale factor and finish off Unit 7.